Yes, one thing that we didn't do, and I like to do it now. Don't get scared. It's nothing really. Express the integral. So they're giving us the integral from 1 to 3. Oh, you give me, anyone. I'm sorry, problem 7. Who would like to give me their problem 7?
I can.
Okay. Sean, what is your...
And you said it's express the integral as
Yes.
a limit?
Yes.
It is, the upper limit is 5, the lower limit is 3, and it is x divided by 1 plus x to the third dx.
Perfect. So remember, this is a limit as n approaches infinity from the sum from delta x f of xi from I equals 1 through n. This part we need to remember. Okay, so I need to determine this piece, and I need to determine this piece, and I just change the integral, the definite integral, into the limit of the Riemann sum. That's all they want. We're not able to calculate any of this. They're only saying change this into this, as if you could calculate it, but we can't. Okay, so then I have to find delta x. So what is delta x? B minus a divided by n. B minus a divided by n. 5 minus 3 is 2 over n. That's our first prep. Second prep is xi. Remember, the interval is 3 to 5. So therefore, xi will be 3 plus I delta x. So this is 3 plus 2 I over n. And final prep, so I have this, is 2 over n. Final prep for this piece, is when I plug in this in the given function. This is our f of x, of course. No question there. So our f of x is x over 1 plus x to the third. And now f of xi is this. I just have to plug it in. And I'm done. No one can do anything. They shouldn't do anything. This is it. Just plug it in. So 3 plus 2i over n, 1 plus 3 plus 2i over n to the third power. And I have to admit, this is horrible to plug in. But in the calculator, not on paper, is fine. So then, final answer, 3 to 5 from x 1 plus x to the third dx. And notice that this function is continuous, is not continuous at -1, but -1 is not here. So this is the limit as n approaches infinity from the sum delta x 2 over n, of course from I equals 1 through n, and just copy that. Don't do anything, copy it, you're done. In other words, this is an exercise on those 3 preps for the limit of the Riemann sum, although for this we cannot determine anything. We don't know what to do with that. So the 3 preps, delta x, xi, and prep number 3 is f of xi. Anything else from this? We will come back to it. I just wanted to give you an idea. So let's move on. I like to look at jump to 5.5 to look at some definite and indefinite integrals from 5.5. So let's choose from there. And then we'll come back because that is a big one. It has 27 questions. So browse through 5.5 and choose anything you like, definite, indefinite. It's up to you. Anyone, or I will?
Maybe something like number 2.
Number 2.
Yeah.
Can you give us yours?
Sure. So it's I guess the
integral.
The integral of cosine to the 15th, or cosine theta to the 15th sine theta d theta.
Very good example.
U equals cosine theta.
Yes, they're giving us, they're nice. This time they're nice. They're giving us the substitution already. So they're saying use this. Of course that's what I'm going to use because this is the problem. This is not a problem. And if I use cosine theta, is du in the problem? So what will du be equal to if u equals cosine theta? Very good. But that's not enough. I'm not asking for the derivative. I'm asking for the differential. We know there is
d theta.
Very good. Very good. So do I have du in the problem? No problem. Sure, it's right here. What I don't have, I'm going to multiply by -1 twice. And now this piece is du. It has a minus in front, so what? There is no problem when I have to make up just a constant. That's really a factor, of course. So this is u to the 15th du. Nice. And we know that this is negative. We increase the power by 1. And we divide by that same number plus a constant c because this is an indefinite integral. We're asked to find the most general antiderivative. But because it's an indefinite integral, I have to go back and replace u by cosine theta. So minus cosine to the 16th theta over 16 plus a constant c. Anything else from 5.5? Anyone else you'd like to work on? Anything else? I'm looking at 8 or 9. There's a ton here. And let's also look at definite integrals. 21, 22, 22, 23, 24. Let's also choose from definite integrals. So you have some examples. Anyone who would like to give their problem? Any problem? Well, I'm going to choose 26 that I see then. We can do yours if you like. Anyone? 26? No one wants to look at 26? Well, I will. So sine inverse, do not consider this 1 over. It's arc sine over the square root of 1 minus 64x squared dx. So I see a function inside another function, and I would like to get rid of this. That's my first thought. So I'm going to say let y be 8x. But is dy in the problem? What does dy equal to? Dy is 8 dx. Do I have 8 in there? No, that's not a big deal. Multiply the numerator by 8, multiply the denominator by 8. If I simplify, I still get 1. Okay, so I have 1 over 8 in front, the integral from. Don't copy the limits of integration. So now I see 8 and dx. These two form the dy. This is sine inverse of y over the square root of 1 minus, when I put this in here, I have y squared. Because when I square y, I get 64x squared. Now the limits of integration. When x is 0, y is 0. When x is 1 over 16, this is 1 over 2. Okay, my next step. Now I say, oh, okay, I see what's going on here. Let me denote the sine inverse by t. But is dt in the problem? Yes, it is. So then I continue with 1 over 8 in front. The integral, do not copy the limits of integration. The numerator is t. Dt is dy over this. This is dt, and this is t. Very nice. When when y is 0, which function, when y is 0, which angle has sine 0? And that's 0. And when I plug in 1/2, which angle has sine 1/2? And that must be, we talked about that again today, 5 or 6. It cannot be easier. T squared over 2, I increase the power by 1 and divide by the same number, from 0 to pi over 6. I don't even have to plug in 0 because it would be 0. But I have 1 over 16 times, when I plug in pi over 6 and square it. The numerator is pi squared. The denominator is 16 times 36. I'm lazy. 16 times 36, 576. So in this particular problem, I really went through 2 substitutions. One, when I substituted whatever for 8x, I wanted to change 8x into something else. Then I said, oh, okay, I don't like this, too heavy. So I said, okay, if I denote this by t, then do I have dt in the problem? Yes, I have dy over this, which is dt. And this piece is t. So now it's just t dt, which can be easier than that. We can't find anything easier than to integrate t. So it required a couple of steps. Is there anything that you would like to work on from 5.5? Anything? Anyone? Or I will choose. I
I
couldn't
don't
hear
have
you.
anything
Which one?
No, I was just gonna say I think it still requires like a lot of practice on our parts before we are able to tell like what exactly we need
Right.
help on. But this really helps a lot, just seeing you go through. So
Okay. Would like me to choose something else or go back
I think you choosing another one might be best.
from 5.5 or from
Uh,
the previous sections?
Maybe from the previous ones. I don't know.
Okay, very good.
Really saying anything.
Yep, let's
so.
go back to 5.4. I'm clicking on 5.4 now. Just evaluate the integral without, these are easier. What I would like to look at I would like to look at something that I have not done in class, which is problem 7. And this is in 5.4, from 5.4 web assign. It says find the general antiderivative of the general indefinite integral, which is the general antiderivative. So we are given this, cosine x plus 1/5 x dx. Which function prime is cosine? No problem. Negative sine x. Oh, I'm sorry, positive sine x. Thinking backwards. So sine prime is cosine. And then plus 1/5 x squared over 2 plus a constant c. Or sine x plus 1/10 x squared plus a constant c. What they want us to do now is to choose a graph. They are giving us 4 options for this. And they want us to choose a graph. Well, what we can do is create several functions in the graphing calculator with c equals 0, c equals -1, c equals 10, c equals 5, whatever, and see the pattern, and then choose. So in y equals, clear whatever you have, and let's put this function with 3 or 4 different c values. So sine x plus, I'm going to write 0.1 x squared, and then I'm going to say minus 2. Minus 2. Okay, I'm going to create another function, sine x plus 0.1 x squared, and I'm going to put plus 4 or 5. Another one, sine x and then plus 0.1 x squared, and let's say plus 8. And I'm just going to graph these. Let me change, oh, I have to let it go for a moment, but I wanted to change the viewing window. But it gives me 3 graphs. If I change them or I don't, which of these graphs will you pick? So in my example, 2 of them are facing down. So you can disregard those, of course. 2 of them are facing up. And I have to choose which one. If they're giving us some C's in there, I just disregarded that and I just put in my own C's. But they're giving us C, -5, 0, 5, 10. This is what I see for all of them. And you will be able to identify which one. And that's what they illustrate with this example is that simply this is a family of functions. They all have the same graph. They all differ by a constant. So the distance between this graph and the next is just the constant. All graphs have to be identical. Any questions on this? Problem 7. I didn't show an example like that in class, so when I saw it right here, I said, no, I have to do that.